When we introduced quantum theory in the previous module, we noted a relationship between the quantum numbers and the periodic table. Here, in our discussion of electron configurations, we find this idea again. So far in this module, we've talked about energy level diagrams, electron configurations, and blocks on the periodic table. I'd like to suggest that these are three different ways to represent the same thing, namely, where are the electrons? We start with our energy level diagram and go up as far as 3p. For our example, we'll use chlorine. Chlorine is element number 17 on the periodic table, so we need to put 17 electrons into our diagram. We can also write the electron configuration of chlorine 1s2, 2s2, 2p6, 3s2, 3p5. If we look hard, the configuration is just another way to express the same information that is contained in the energy level diagram. There are 2 electrons, shown by the 2 arrows, in the 1s orbital, 2 electrons in 2s, 6 electrons in 2p, 2 electrons in 3s, and 5 electrons in 3p. When we write the noble gas abbreviation with neon in square brackets, we're simply using an abbreviation for the 10 lowest energy electrons. Note that the highest occupied orbitals, 3p, along with the 3s electrons, represent the valence electron configuration. The energy level diagram and the electron configuration are also related to the periodic table. If one reads the periodic table like the page of a book, the first 2 elements are hydrogen and helium, which have electrons in the 1s orbital. The next 2 elements fill up the 2s orbital. Going across through the next 6 elements, the 2p sublevel is filled. Next comes 3s. After that, 3p. A common practice, which we will follow here, is to list the sublevels in the electron configuration in the same order as they appear when reading through the periodic table. We have also been talking about the highest occupied orbital based on the location of the element on the periodic table. The orbital energy diagram clearly shows 3p is the highest occupied sublevel, which is the same as saying that the 3p orbitals are the highest occupied orbitals. We also identify 3p as the highest occupied orbitals from the electron configuration. When we understand the block nature of the periodic table, we can see that the same information is contained in the table. We can identify the s block, the p block, the d block, and the f block. We do need to remember that the top of the s block corresponds to filling the 1s orbital, the top of the p block corresponds to filling the 2p orbitals, the top of the d block is 3d, and the top of the f block is 4f. This comes from our discussion of quantum numbers in a previous module. Locating chlorine, we can identify the highest occupied orbitals as 3p. Since it is the 5th element into the p block, we can predict a 3p5 configuration. So again, the energy level diagram, the electron configuration, and the periodic table all convey the same information expressed in 3 different ways.